Good afternoon, students. Welcome to PowerPoint YouTube class. I am your teacher, Oyeninde Tunde Daniel, and in this PowerPoint class, our topic for deliberation is simple machines. Our topic for deliberation is simple machines. As I always say, in order to maximize the benefits embedded in this PowerPoint YouTube class, it is advisable that you watch the YouTube class as many times as possible. It's in doing that you will get adequate and correct information on the topic that we are about to discuss. Although I want to believe that we already had a Zoom class, part 1 Zoom class on this topic. And again, this PowerPoint YouTube class will be divided into 3 because all the objectives stated in this video cannot be achieved in one class. So the objective that cannot be achieved in this section come next week. I will ensure that they are included in PowerPoint YouTube class for next week. And our objective for this class are to define machine, state examples of simple machine, describe a gear, list application of a gear, define lever and state the classes of lever with relevant examples, define efficiency as related to machine, use efficiency formula to solve problem related to machine, define the factor that the efficiency of a machine depend on, define mechanical advantage and velocity ratio, state the formula and use the formula to solve problem related to machine, and the last but not the least, state ways to take care of list ways to take good care of any machine. Now, when we say machine, what exactly do we mean by simple machine? Simple machine are machines with few or no moving parts that are used to make work easier. I repeat again, simple machine are machines with few or no moving parts that are used to make work easier. A simple machine uses a small force called effort at one point to overcome a large force called load at another point. So, the brief description of a machine is that it uses a small force called effort at one point to overcome a larger force at another end called load. So in a simple machine, there are two forces in action. The smaller force, which is called the effort, and the larger force, which is called the load. So the ability to apply a small force called effort to overcome a larger force called load is what makes a particular object to be described as simple machines. And there are basically six classes of simple machines, and they are the inclined plane, the lever, the screw, wedge, pulley, wheel, and axle. These are the classes of a simple machine. So let's go to the description of each of them. We have lever. Lever is one of the most commonly used simple machine. It makes lifting of load easier by using a fulcrum to redirect effort over a long distance. So the most important use of a lever is that it makes lifting of load easier by using a fulcrum to redirect force over a long distance. Example of lever are a seesaw, a claw hammer, a fishing rod, a crowbar, a bottle opener, etc. They are all examples of lever. Now we have classes of lever. Levers are classified into 3 based on the position of the fulcrum. So the position of the fulcrum with relative to the load and effort form the basis for classifying lever into 3. And as such, we have first class lever, second class lever, and third class lever. For first class lever, the fulcrum is between the load and the effort. When the fulcrum is between the load and the effort, it is called a first class lever. And common examples are plier, scissors, crowbar, claw hammer, and seesaw. They are all examples of first class because the fulcrum is in between the load and the effort. The diagram here shows what a first class lever looks like. We also have a second class. A second class lever is a situation where the load is between the fulcrum and the effort. When the load is between the fulcrum and the effort, it is called a second class lever. An example include your crackers, your wheelbarrow, and bottle opener. They are all examples of second class lever. However, there are other examples. So the three listed in this PowerPoint is not all the examples of second class lever. There are many more. But all you need to know is that when the load is between the fulcrum and the effort, that class of lever is referred to as your second class, as shown in this diagram. We also have a third class, first class, a third class lever. A third class lever is a situation where the effort is between the load and the fulcrum. When the effort is between the load and the fulcrum, it is called a third class lever. An example of third class lever include the sugar tongue, broom, fishing rod, and stapler. They are all examples of third class lever. They are third class lever because the effort is between the load and the fulcrum. This diagram shows what the third class lever is with the effort between the load and the fulcrum. We also have here first class lever, second class lever, and third class lever. All in this content, the position of the fulcrum with respect to the load and the effort form the basis for classifying lever into three, which are first class, second class, and third class. This takes us to an inclined plane. An inclined plane basically is a slanted surface to make lifting easier. So what an inclined plane does is that it makes lifting easier. An example of situation where inclined plane is used, we have a ramp, a stair, a switchback road are all examples of inclined plane. And what do we use inclined plane for? Inclined plane are commonly used in hospital, and this enables patients on the bed to move from one floor to another rapidly and safely. We also have second, aircraft evacuation slide allow people to rapidly and safely reach the ground from the heights of a passenger airline. And the third use of inclined plane is that it's used in loading ramp to load and unload goods to the trucks, ship, and plane. So this diagram basically shows what an inclined plane is. I believe you can see the slanted surface, and we can see a man trying to push a wheelbarrow full of load to climb a particular height. So it's make easier to do this. The machine that will make this easier, or the simple machine that will make the lifting of the load easier, is basically an inclined plane. We can also see the application of inclined plane. As I said earlier, when you go to SS1 and SS2, you also meet this topic, which will more in more detail and complex than what it is today. So we also have a screw. A screw is a simple machine that requires a lot of turning. Screw require a lot of turning in its operation. And examples of screw are your bolt and nut, your car jack, and carpenter screw. They are all examples of a screw, and basically it is also what? A simple machine. This is what a screw looks like. Now, what do we use a screw for? Screws are used to hold door to door frame. If you check your house, you see that a door can be held with the use of a door frame. Screw can also be used to drill holes in hardwood. To drill hole in a hardwood, you need also to apply screw. And screw are used in car jack to raise a car in order to change a flat tire. To change a flat tire, you need a screw. You need a car jack, and in that car jack, there is a screw attached to it. So this shows us the three uses of a screw. However, there are more uses. If you want to know, you can check your Google or internet to get more information. A wedge. A wedge can be considered as a moving inclined plane or two inclined planes joined back to back. Some examples of wedge include an axe, a knife, a saw, a pickaxe, a needle, and a nail. These are all examples of wedge. Now, what do we use a wedge for? A wedge can be used to cut metal. A wedge can also be used by forest workers to cut tree trunk. So to cut tree trunk, the simple machine that is used in doing this is called a wedge. Wedges are also used to engrave plates of metal or stone with picture and weights. So this is a good diagram that explains everything that I've discussed about the uses of wedge. Remember, I say wedge can be used to cut metal. Wedge can also be used by forest workers to cut tree trunk, and wedges are used to engrave plates of metal or stone with pictures and words. This is your homework. Please, you are to write down this homework, and in our Zoom class, I will call on each of you to tell me what he or she was able to do in this homework. The first homework says a pulley system raises a load of 400 Newton when an effort of 120 Newton is applied. Calculate the force ratio. Here, force ratio is also called mechanical advantage. And mechanical advantage simply means the ratio of load over effort. So for the other one, you need to make a little research in order to solve the 1, 2, 3, and 4 question. And if you do that, it will aid you in understanding our next topic, which has to do with mechanical advantage, velocity ratio, and efficiency of a machine. So far, so good. We've looked at 4 different simple machines. In our subsequent bulletin, we look at the remaining types of simple machine, and we discuss each of them in details. Thank you for your cooperation, and God bless you all. Bye.